Our next topic of discussion is going to be static routing. Now, there are two types of routing that a router can perform. Remember when I went through the IP routing process and I said that router 1 had information in its routing table on how to get to network 20.20.20.0? Well, now we're going to cover the process of how that information got in router 1's routing table in the first place. So, there are two types of routing that can happen. One is called static routing, which is the process of manually entering routes to remote destinations in your routing table. And the other one is dynamic routing, which is when routers talk to each other and automatically share routes to remote destinations or remote networks. So the first topic between the two types of routing we're going to cover is static routing. Once again, static routing is the process where you manually enter routes into a routing table. So the skeleton for the command to create a static route is from config mode, you're going to say or type IP route. Then there's a field for the destination network where you're trying to get to, or the network where the router is trying to route to. So the IP address or the network address of that destination. Then the destination mask. So the mask of that destination network. Then something called the next hop IP address, which is the IP address of the router immediate to you once traffic leaves your router. So the IP address of the interface of the router that is facing you, that is immediate to you once the traffic from your router leaves your interface. Or this little line in Cisco language means the word or. So you could either type in the next hop IP or the exit interface of the router, of your local router. So let me just draw a little diagram here to explain this better. Let's say this is router 1 and it is connected to router 2, and this network is 100.10.10.0/30. /30 because this is a point-to-point link. And router 1 is .1 and router 2 is .2, and the interface are serial 0, 0, 0, and this guy is serial 0, 1, 0. So after you have typed in your destination network, the network you're trying to get to, so in this example, if there is a network connected here on Fast Ethernet 0, 0, and the network is 150.10.10.0/24, if router 1 is trying to get to network 150.10.10.10, I would type IP route, then my destination network, which is 150.10.10.0, that number would go here. Then the destination mask, which is /24, that number would go here. So you would type in 255.255.255.0. Then you could either pick the next hop IP address. Once traffic leaves my router, the next IP it encounters, the next IP that traffic encounters is this address right here on router 2, the address of the serial 010 interface, which would be 100.10.10.2. Or I could simply type in the exit interface. So my exit interface on router 1 would be serial 000. So you have two options, either the next hop IP option and the exit interface option. As you will see, there are certain rules as to when to use the next hop IP and when to use the exit interface option. And I will go over these rules during our lab. Next, you have something called the administrative distance. Now, the administrative distance is the trustworthiness of a routing protocol. The lower the administrative distance, the better the router will trust that route. So if there are two routes available or two means of getting somewhere, so two routes available to a router to the same destination, and they were acquired by different means. Let's say one route was acquired by you configuring a static route, and the other route was acquired by something called Route Information Protocol that we will cover later in class. It is a dynamic routing protocol. Static route's administrative distance is 1, and route information protocol's administrative distance is 120. The router will prefer the route with the lower administrative distance. So the static route would be preferred over the route learned by route information protocol. So I've put all the default administrative distances on the board. A connected route has an administrative distance of 0 because it's connected to you. It's a connected interface. We've already seen this in our IP routing table during our previous lab. When we executed the show IP route command, you saw a little C on the left-hand side. Well, that stood for connected route. So a connected route has the lowest administrative distance because it exists on the router itself, and the AD, or the administrative distance, is 0. A static route has an administrative distance of 1. A route information protocol route, or a RIP route, has an administrative distance of 120. This will be covered later, and I will point this out. Enhanced Interior Gateway Routing Protocol, or EIGRP, again a dynamic routing protocol, which will be covered later, has an administrative distance of 90. And Open Shortest Path First, which is again a dynamic routing protocol covered later, has administrative distance of 110. And as I cover these routing protocols, I will point out these administrative distances at that point, but I wanted to list them out for you all in one place for now. So that concludes the command syntax portion of how to create a static route. Before I move on to my static routing lab, I just wanted to draw out our topology that we're using in our lab on the board. I forgot to draw the two sub-interfaces that exist here on router 2. So we have F0/1.10 and F0/1.20. And the address over here is 10.10.10.254. And the address here is 20.20.20.254. We're not going to worry about switch 8 that sits over here with the host sitting over here. Okay? We're just going to worry about these two interfaces right here. So, in our lab, what we're going to do is we're going to try and create static routes from router 201 to be able to reach this 10.10.10.254 address on router 2, which is the address on fast Ethernet 0/1.10, and the 20.20.20.254 address, which sits on router 2, F0/1.20. On router 2, I'm going to be creating a route so that I can send traffic this way, coming this way, down to router 2's fast Ethernet 0/1.10 and fast Ethernet 0/1.20 interfaces. Now, by default, does router 201 know about the 10 and the 20 network? The answer is no. By default, router 201 only knows about its 200.200.200.0 network with the .2 address residing on its serial 010 interface. Now, as I said, static routing is the process of manually entering in routes or making entries in the routing table to remote destinations. So, as far as router 201 is concerned, network 10 and network 20 are remote destinations because they are not directly connected to router 201. So if we try to ping from router 201 to any one of these addresses, 10.10.10.254 or 20.20.20.254, without having routes in the routing table, it's not going to work. So I wanted to put up the topology on the board, and then we're going to pull up the same topology that we have on our lab. This is basically the lab topology. All I'm missing are the 4 switches between router 1, 2, 3, and 4. And as always, I drew this as a logical diagram. So you don't put switches on a logical diagram. On a physical diagram, yes, you can include switches. So since this is a logical diagram, I've excluded the switches out. So let's go ahead and see how this works. We're going to try and route from router 201 to the 10.10.10.0/24 network and the 20.20.20.0/24 network.